Are your microservices causing more headaches than solutions? In this video, we break down the top microservices anti-patterns that can sabotage your architecture and show you how to avoid them. From the dreaded distributed monolith to overcomplicating communication and data inconsistency nightmares, we've got you covered. Microservices can provide great benefits in terms of scalability, flexibility, and maintainability, but if not implemented carefully, they can introduce complexity and inefficiency. Here are some common anti-patterns in microservices architecture and ways to avoid them. Distributed monolith. What it is: services are technically separated but tightly coupled, often requiring coordinated deployments. Problems: reduces the benefits of independent deployment and scalability. Changes in one service can ripple across others. How to avoid: ensure services have clear, well-defined APIs. Use asynchronous communication where possible. Implement proper service boundaries aligned with business domains. Domain-driven design. Too many services too soon. What it is: over-engineering by breaking down an application into too many microservices from the start. Problems: increases complexity, overhead in managing services, and inter-service communication. How to avoid: start with a modular monolith and extract microservices as needed. Identify clear performance, scalability, or organizational needs before splitting. Lack of service autonomy. What it is: services rely heavily on each other, sharing databases or business logic. Problems: reduces fault tolerance and leads to cascading failures. How to avoid: each service should own its data, database per service. Encapsulate business logic within services. Use API contracts instead of direct sharing. Inconsistent data management. What it is: poor handling of distributed data, leading to data inconsistency and integrity issues. Problems: difficulties with transactions and eventual consistency. How to avoid: use patterns like event sourcing and CQRS, command query responsibility segregation. Embrace eventual consistency where appropriate. Use sagas for managing distributed transactions. Overcomplicating communication. What it is: over-reliance on synchronous communication, e.g., REST, between services. Problems: increases latency, reduces resilience, and risks cascading failures. How to avoid: use asynchronous messaging where possible, e.g., message queues, event-driven architectures. Implement circuit breakers, retries, and timeouts for synchronous calls. Ignoring observability and monitoring. What it is: failing to implement centralized logging, monitoring, and tracing. Problems: makes it hard to diagnose and troubleshoot issues in distributed systems. How to avoid: use centralized logging, e.g., ELK stack, Graylog. Implement distributed tracing, e.g., Jaeger, Zipkin. Use metrics and monitoring tools, e.g., Prometheus, Grafana. Versioning chaos. What it is: poor handling of API versions and backward compatibility. Problems: breaks client applications, forces unnecessary updates. How to avoid: use semantic versioning for APIs. Implement backward compatibility in APIs whenever possible. Use feature flags for incremental rollouts. Neglecting security. What it is: inadequate focus on securing inter-service communication and data. Problems: increases vulnerability to attacks, e.g., man-in-the-middle, unauthorized access. How to avoid: use mutual TLS for service-to-service communication. Implement API gateways with authentication and authorization, e.g., OAuth 2, JWT. Regularly audit and test for vulnerabilities. Single point of failure. What it is: relying on a central service or component that, if it fails, takes down the entire system. Problems: reduces system resilience and availability. How to avoid: design services to be stateless where possible. Use load balancing and replication for critical components. Implement failover mechanisms. Overlooking deployment and infrastructure automation. What it is: manual deployments and lack of CI/CD pipelines. Problems: increases risk of errors, slows down development, and hampers scalability. How to avoid: automate deployments with CI/CD tools, e.g., Jenkins, GitHub Actions, GitLab CI. Use containerization, e.g., Docker, and orchestration tools, e.g., Kubernetes. Adopt infrastructure as code, IAC, for environment consistency, e.g., Terraform, Ansible. Ignoring team and organizational alignment. What it is: misalignment between the microservices architecture and team structure. Problems: increases communication overhead, confusion about ownership. How to avoid: align teams with service boundaries, Conway's Law. Foster a DevOps culture where teams own the entire lifecycle of their services. By being aware of these anti-patterns and consciously designing systems to avoid them, you can harness the full potential of microservices while minimizing common pitfalls. Don't forget to like, subscribe, and comment below with your microservices experiences.